Hello, in this video we want to look at ellipses. They're another conic, so let's talk about ellipses. Alright, and what we mean by a conic is imagine again that we have a cone and we slice through the cone with a certain angle. If you take a look at the shape that can be created, it's an ellipse. An ellipse is kind of like a somewhat elongated or distorted circle. All right, so let's go to the next thing here. Whoops, and there we go. An ellipse, kind of like a parabola, is based on distances. It's a distance concept generated graph, basically. With the parabola, every point on a parabola was the same distance away from a focus as it was from the directrix. Here, our ellipse, and we'll just use this one as the example, any point on the ellipse, say the point shown here, x, y, has a certain distance to each foci. There are two foci with an ellipse. There was only one focus for a parabola. So you get this one distance here and you get this other distance. The sum of those two distances will be the same for any point that we pick. So if I pick another point, say I pick a point over here somewhere, so let's say that's the point, then the distance from this point here down to this focus is longer than this one, but the distance from here to this focus is shorter than this one. The sum of the two distances, no matter which point I pick, would all be the same. All right. An ellipse has a center. So the center of the ellipse, it's a point that's not on the ellipse. It will have the two foci, which are inside the ellipse. They're not on the ellipse either. But then the longer side, or the longer, let's say, axis, the major axis of an ellipse, you'll have a point at each end, and that's called the vertex. So there's two vertices, basically. And then the axis that's considered the shorter axis, the minor axis here, will have a point up here that's called the covertex, and another one down here that's the other covertex, or you have two covertices. All right? So the important concepts that go along with an ellipse are the center of the ellipse, the two foci, you have a major axis that has vertices on each end, basically, and a minor axis that has two covertices on each end. All right. Okay, if you have a, let's call it a horizontal ellipse. So I like to think of an ellipse as kind of like a football, and this is a football lying on its side. So here's the ellipse. It's got a horizontal major axis, which means this is the long axis here from vertex to vertex, going through the center and through the two vertices, all right? Or the two foci, I should say. And then it's got its minor axis, which goes through the center and connects both covertices. So I'm going to use cov for vertices, F for foci, V for vertices, and then we have some other things. All right. There's going to be certain links or important things that are important here in kind of like letters. Like in parabolas, H, K, and P were the important things for a parabola. For an ellipse, it's going to be H and K is still important. So here's H and K. H and K is the center. So the center is the point H, comma, K. And then you're going to have various other links. And you have some things here, and I don't really use these, plus or minus things to find the other things. I just use some common sense, which I'll get to here in a second. The distance from the center to a vertice or a vertex is going to be a length called A. So this is A from here to here. The length from the center to a foci will be C. And then the length from the center to a covertice will be B. Now, a couple things that you want to look at here. A is bigger than B because A is half the length of the major axis. B is half the length of the minor axis. So A is bigger than B. So A bigger than B. That'll always be true in an ellipse. Okay, define C. C has a relationship compared to A and B, or with A and B. C squared is equal to A squared minus B squared. So knowing two of these, A, B's, or C's helps you find the third one. All right, down here you see the standard form equation of an ellipse that is, whoops, I don't know why I bounced down there. I'm supposed to be on this screen. It's okay, it's still the same thing. Here, this horizontal an ellipse will always look like this in standard form. It's going to be x minus h squared in the numerator of the first term. You'll have a y minus k in parentheses squared in the numerator in the second term. They're going to be added together. You're going to have 1 on the right side, so they're always equal to 1. The longer thing is underneath the x for this one. The longer of the two a's and b's is a. So you get a squared is underneath the x term, or x part that's squared. And what that means is the longer thing goes in the x direction if you have a horizontal ellipse, an ellipse that looks like a football that's just lying on the ground. All right. The shorter thing, the b squared in this case, is underneath the y part that's being squared. And that's because this is the shorter part compared to this part over here. All right. The only thing that changes whenever you go into the vertical ellipse, or the football that's on the tee, and that's this case here, the only thing that changes at all, basically, in the standard form equation is you just move the b squared underneath the x part that's being squared, and the a squared underneath the y part that's being squared. Why? Well, in this case, the longer part is a y direction. This is a longer part. This is the major axis. Now, if your football's sitting on a tee, standing kind of vertical, all right? So A is bigger than B, as it was in the prior case, and so the A part here is in a kind of a y direction, so it's going to go underneath. It's going to go underneath the y part. So everything else is pretty much the same. It's still A is bigger than B. C squared equals A squared minus B squared. So you're going to want to know from your information, is my ellipse vertical like you see here, or is it horizontal? All right, and then everything else can be kind of found, So here's the major axis for the vertical one, and notice that the major axis goes from vertex through, or from one of the vertices through a focus, through the center, through the other focus, and up to the other vertice. Okay? So let's take a look at this problem here. And I'm going to exit out a wee little bit so I can write on this one here. All right. So here we want to find the, and maybe I can make it bigger. Let me see. I think I can make it a little bit bigger. 200 is probably too big, probably, right? Yep, let's go back to 100. Okay, so that looks pretty good. Here we want to find the center, the vertices, and the foci of an ellipse that's given by what we have right here. All right, but, and let me grab something to draw with here. There we go. And blue will be good. This is not in any standard form. So what we want to do is to put it in a standard form. What we found is that the standard form will have 1 on the right-hand side. So to get 1, I'm going to take this equation here, and I'm going to divide. Let me change color here a second. Color. There we go. Let's go to red. So I'm going to divide both sides by 36. So if I divide this by 36, and I'm writing with my mouse, which isn't the greatest thing, I'm going to divide this entire side by 36 too. But if I do that, I'm going to distribute it to each term. So this will be divided by 36, and this part gets divided by 36. Okay, let me simplify it a little bit. So I'm going to go back to blue or some other color. We'll go to dark blue. So now 9/36, 9 goes into 9 once, it goes into 36 4 times. So basically it looks like this now. X squared over 4 plus, and 4 goes into 4 once, it goes into 36 9 times. So this will be just simplifying the fractions basically. Y squared over 9, and 36 divided by 36 is 1. So now it's pretty much in the standard form. And you might be saying, well, where are the parentheses that are being squared up here? Well, if you wanted to, you could make this, I'll just write it over here. I'll try to draw it nicely, or write it nicely. X minus 0 squared over 4 plus, and again I'll do the same thing here. Didn't draw. There it goes. This will be y minus 0 over 9, and that's equal to 1. All right, so now it is in the standard form, and if you look at it, notice that the bigger thing is underneath the y. So the smaller number is underneath the x part. So this tells us that our ellipse is kind of a vertical one. And there's my attempt to draw a vertical one. So that means that I can locate, what's A and what's B and all of that. So this is A here, or this is A squared. So this tells me, since this is A squared, because I have a vertical one, let me go back just to here. Okay, so this means that A squared is 9, and A is therefore 3. And this tells me that B squared is 4, so B must be 2. And so now I have, this would be H, this will be K, and the only thing I'm missing is C. But I'll write that over here. C squared is equal to A squared minus B squared. So if I square A, I get 9. If I square B, I get 2. So this would be 9 minus, if I square B, I get 4, I should say. So I'll get 9 minus 4, which is 5. C squared would be equal to 5, so therefore C is the square root of 5. Okay, and now we have enough information to find our center, the vertices, and the focus. Okay, in the next video, we'll go ahead and take all this information, find the center, the vertices, and the focus.